Hello students, welcome to a mystery lesson. Suppose you walked into class and this equation was on the board and I asked you to graph it. At first it kind of looks overwhelming, like I don't know what that is. It doesn't look like y equals mx plus b, it doesn't look like a line, I don't know how to do this one. But suppose you were really motivated, like the first person who could graph this wins $500 cash or something like that, and you desperately want to graph this thing. One of the best teachers, not one of, the best teacher I ever had was Dr. James Tanton, and he always used to say, even, with graphing things in trigonometry, like graph y equals sine of x or something like that. If you don't know what it's supposed to look like, you can always go back to how you first learned how to graph things, which was make a table of x's and y's. Just pick some x values. I just picked a whole bunch here, somewhat at random, but honestly not entirely, but you could. And substitute x into the equation and solve for y, and that'll give you a point to plot. Plot the point, and then try another x, and do the algebra, and simplify, and plot that point. And if you plot enough, you might start to see what the graph is. So, I am going to show you how we could, two ways how we could do the first one, when x is 3, what does y equal? And your assignment's going to be to finish this table. So you'll want to refer back to this video for help with some of this algebra. So if x is 3, here is a way to do it. So I took the original equation, which is here. I substituted x is 3, and everything that follows is my attempt to solve for y. So let's see, 3 plus 4 is 7. 7 squared is 49. So there's my 49. Y minus 7 squared, of course, means y minus 7 times itself. That's what squared means. Equals 64. So here I had to FOIL or use the distributive property, y squared. Y times negative 7 is negative 7y. Negative 7 times y, same thing. Negative 7 times negative 7, positive 49 equals 64. And I know I'm speaking quickly, but again, you've got a pause button and a rewind button, and you should use them. Next, I combine like terms, so I got negative 14y here. I added my like terms of 49 plus 49 on the left side of the equation to get this 98. I realized it's a quadratic, so I got a 0 on one side. I subtracted 64 from both sides to get that 0 that we need. So here's my quadratic formula. My quadratic equation. And to solve it, I'm going to use the quadratic formula. A is 1, B is negative 14, C is positive 34. There they are. There's the quadratic formula, solving for y. Substitute your values. And you go through your algebra, and you can pause the screen if you need to. I'll explain down here, when I had the square root of 60, remember we simplified square roots in our notebooks. Root 60 simplifies to 2 root 15. So I got it down to be this, and I noticed I can divide both of these numerator terms by 2. So my final answer was 7 plus or minus root 15, which is the answer for y. That's a way to do it. That's not how I recommend you do it. Check this out. Same starting equation. Don't worry about what's on the bottom if you can see that. Same starting equation. I substituted x. 3 plus 4, 7 squared, 49. Now, this is a special type of equation in the sense that if I subtract 49 from both sides, then I get something really user-friendly. Y minus 7 squared equals, what is that, 15. This is a special form for my equation. I've got the entire left side of my equal sign is some number in parentheses being squared? Well, I can solve that real easily. I can get rid of that squared. Now, a little side note here. If I want to solve the equation x squared is 25, in geometry we're so used to just saying, oh, square root both sides. That's correct, but in geometry we're usually looking for positive answers, you know, the side of a triangle or the measure of an angle. But if we're really being careful, that number being squared that makes 25 could be positive or negative root 25, right? It could be positive or negative 5. 5 squared is 25, but negative 5 squared is also 25. So when we put a square root on both sides of an equation, we're supposed to remember to say it could be positive or negative, unless we're certain the answer can only be a positive. So back to this, I've got some number, the number is y minus 7, that is being squared. I can get rid of that square by square rooting both sides, as long as I remember to put a plus or minus over here. And what that does is this radical and this square are inverse operations that undo each other. So the left side of my equation is now just y minus 7. And the right side of my equation says plus or minus root 15. I add 7 to both sides. 7 plus or minus root 15. That sounds familiar. 7 plus or minus root 15. Much less work. So I do want to stress this trick of square rooting both sides of the equation only works in special circumstances. I would not be able to do it on this equation. I would not be able to say, oh, I want to get rid of this square, I'll just square root this whole both sides. It only works if you have the entire side of the equation as a group is being squared. Then you can square root both sides. And the equation we're dealing with is in that form. When you fill in your x value and add it to 4 and square it and get some constant here, you can subtract that constant from both sides and you're going to have y minus 7 in parentheses squared. So I recommend when you finish this table to do it this way. You may have to watch what I did here once or twice more to get the hang of it, but it's a big, big time saver. So back to my table. If y is 7 plus or minus root 15, I'm going to write under my y column, when x is 3, y is 7 plus or minus root 15. But these are going to be points that we're plotting. Remember, we started with graph paper. We're going to be plotting these points. So I need to know approximately what that equals. So in my calculator, if I type in 7 plus the square root of 15, and after I type it in, I'll show you what it looks like. So there's 7 plus the square root of 15. So I'd say for plotting purposes, we could round these off to the nearest tenths. So it looks like 10.9. And I also have to check 7 minus the square root of 15. And that's going to be about 3.1. So 10.9 or 3.1. So over here, 10.9 or 3.1. So after you complete this table, what you'll want to do is get a piece of graph paper and plot all your answers. 3, 10.9, plot that point, write 3 up 10.9, and also 3, 3.1. So write 3 up 3.1, put a dot there. So if I got 2 answers, I want to plot both of them. Apparently they're both going to be on my graph. So your assignment is to fill in these x values, show the work of course. I recommend the fast method I show you. Get the exact y values, show their rounded off values, plot, and we'll see what happens next time we touch base. Have fun.